All right, good morning, YouTube. Just doing an overview on some of these test tiles and ingots that I've made. This is the Puritan right here. This is lime. Well, it's not even the Puritan. I should say there'd probably one more back here. This is lime with bast and shiv deliberately crushed. This is the shiv only. This was purposely crushed, bass and shiv, purposely crushed bash and shiv. This is ground fiber, just, down to nothing near. This is ground down to nothing, but put back together with adhesives. But we'll get to this in a minute. For the Puritan that likes if the tile, these are 9-inch tiles, if it was like 12 inches, it would be R75. Do the math for the rest of the, I'm not going to try to break it all down. And no, I don't give out recipes or you got to test. That's what this is. I'm just showing you what it's capable of. I'll tell you what I made it with. You do your own testing. I'm not going to be liable. Because you want to do it almost good enough. Okay. When I test this is not done almost good enough. I'm a researcher and it's repeatable. But enough on the disclaimer. This one, if it's hit, it's going to make a dust like that. If you can see this dust, but when it's sealed into a wall, it's no longer going to do that. And this was deliberately made with very little slurry or the lime, so you could actually see what was in the block is what it was for. This again is concrete done predominantly the same way. Excessive amounts of shiv. There's no bass in this one. It has a nice ring to it. I mean, this does too. These are all nice. This is what hempcrete or hemp lime is. I mean, when people show you the houses, if it looks white, it's lime. If it looks gray, it's Portland. Then they can step it up from there, is what I'm trying to get at. It's been fortified, and fortified only means that it makes it sticky. I should say it's been stabilized to make it sticky. Fortification means it has like acrylic or latex, and acrylic is a monomer. It can grow roots into the medium, into organic medium, and that's why you'd use an acrylic. But some people can be allergic to it. But this one, it's been stabilized with caliche clay and a little bit of fine ground sand, just desert sand from southern Colorado. But does a real nice job. You can knock on this one. This is where it would start. These would be self-supporting if it had framework to hold up, the big mushroom top of a roof. The weight is about 250 pounds per square feet. But the walls are more than self-supporting. If you change that big mushroom top of a roof to hemp, it would be lighter, and then this could actually support the entire house. But from here on, this will actually support a conventional roof. This goes above and beyond 250 pounds per square inch, and that's not just static load. That's an aggressive testing. But concrete has a drawback, and I don't know if I can zoom in there. The Portland is not capable of binding to an organic material, and no sand and gravel is not organic; it's mineral. So you don't get for people that don't realize that. But an organic, Portland doesn't do well. Lime does not do well either. It probably doesn't even do as well as Portland. The Portland has clay in it, and that's what gives it a slight advantage over the lime. This is fortified. It has the bentonite, but it's lime, and now this actually holds to the fiber. The bentonite makes it sticky enough. Does it hold perfectly? No. It's not capable of that without fortification. And that's the next step, is adding an acrylic, a monomer, like an acrylic resin, into the Portland. You can get this. And it's Portland, but it's held perfectly. Won't zoom up. It's held perfectly to the fibers. This is still green, so I'm not going to hit on it. But it's not giving up anything on the fiber. It's not shrinking away. In bast, hemp, the shiv and the bast don't bring in moisture or won't take on moisture. You'll play hell even wetting it down to do it. In hot water works best. Just a hint, I'll save you a little bit of time on that. But is to get it to fortify with acrylic, to hold to the organic material. Now's when the crazier strength starts coming in, because bast is, pardon me, hemp bast fiber is twice as strong as steel for its weight. The shiv is as strong as any hardwood. I would compare it to like aspen, non-grain orientated hardwood. But it's strong is what I'm trying to get at. This is purposely laid up. The layers, there's like 5 layers in that. I don't know if you can see them, but there's 5 layers. It was meant to be this way strong. In one of the videos down here, it's holding up a few hundred pounds this way and only holding it on the very edges. So it's extremely stronger than what it was designed to be. We got a winner there. This is the same composition, but solid, is the tube. And I made this column. It was a hollow column. And down here again, you're going to see this one pop up. And it's sporting a 5,500-pound truck. On its 3rd test, it fails. And what fails is the glue, the adhesive, pooled. It was a bad cast, and it didn't compact. And it pooled, and it froze at -7. So the fiber didn't fail. The adhesive failed. On its 3rd test, it was lifting up 5,500 pounds like a boss. This will do the same. It's just solid. But the fiber composition is the same. It's crushed material with a PLA adhesive. This steps up a different direction. This is nothing. This will be stronger even yet. This is purposely ground fine, but then using only nothing more than Elmer's glue. But this will actually be the next step up. Could it be made with other adhesives? Yeah, and it could even be stronger yet. But that's just where this is at. This is where it just gets wild. You couldn't hurt this with a sledgehammer. I try. I zoom up on it, like this to show you. I've done this one before. See that spot? You can't even make the hammer with the ball peen part dimple that spot. It won't. The fiber will not even dimple. So, good luck, Skippy, if you try to tear this up. I've tried 4 years. Not just that block, but everything else. The hemp is stronger than any organic fiber we have on this planet. Period. There's no way to say that. It's non-toxic like this. You can plant your plant right in the construction waste. It's fine. As long as you don't use a toxic binder, the material is safe for worms. You can use it for vermiculture, and the worm is, it's not like the skin on your armpits or your crotch. It's like the inside of your mouth. The worm is really super tender, and so there's nothing bad in hemp, period. And it's good for the micro and macrobiology also. So that's just the way it is. I don't know how to say that. I can't say it any other way. And people that dog hemp because it's only insulation, they're talking about that one. They're not even talking about this one. And they're damn sure not talking about this fortified one or these other modified ones. They're only talking about these, and that's what they'll point and say, this is the only thing that we can do. Well, that's not true. Well, if that is, then you need to go back to school. Because there's all these others that you can do also, which is crazy in strength. This is 3/32. It's just all bass fiber. It was put together with the wrong epoxy. That was my bad. I should have read the can better. It can't be struck. The epoxy will fracture. The fiber won't, but the epoxy will. And to show you, I got a piece of it where it was only 1 fiber thick. Literally 1 fiber thick. And I had a guy up here, and that's this. It's a fiber thickness. if you can see that crack back there, is and he was standing on it, punching on it and all that. And I am a martial artist of many years. And so I can hit something fairly faster. And I kept telling him, no, you have to hit it faster if you wish to do any damage. That's the only thing that can tear this up is speed. And so I punched it and I broke it. But not, it's just, it's like a car panel. It would be like, it's cool. But you can't tear that up. Here is the next, it stops here, and then I had 5 more and I took them away because that's just a whole different thing. This is the first start of a geopolymer to use for stabilization and to fortify it. It does both. And it's using magnesium and aluminum and chloride, sodium chloride. But many ways to do this is what I'm trying to get at. You can use all magnesium oxide, magnesium chloride, and that makes that makes all that. But now this is crazy in strength. I don't know if I can do it. This is not even held on. It didn't, without vacuum, it's not going to pull through, on the cast. But here, okay. I did right there. Now that's hitting it like hard. Okay. This is green, or not really. It's not fully cured, but even now it cannot come loose of the organic. That's the key thing. And here on another side, there was a fiber that I did the same right here. I did the same thing with right there, trying to beat this little fiber loose. You can't even exploit one fiber of this. And now from this, and see it, and if the sun was right, you could actually see the crystals, the magnesium and aluminum, with any ide. It doesn't matter what chloride, what source of chloride you use. But any ide, it's gonna make crystals again, and but quite strong. This, wow. How to put that? These two are strong as non-reinforced concrete. They could hold up maybe 200 pounds per square inch, roughly. This gets to the modified ones. Gets to the. It surpasses that, is what I'm trying to get at. By the time you get to this, you're 10 times stronger than non-reinforced concrete. The very next step is a geopolymer. That makes it 50 times stronger. That's why I stopped, because it's lunar. You can't put these next 5 in the same bunch. You could build bridges and stuff in space from here. This is different, is what I'm trying to get at. It's hemp, but it's finally it's a chemical way to turn the hemp to stone, with MgO, with magnesium oxides, and with different. Well, I should just say oxides, and with chlorides, and modify it that way, and to make it bind to an organic, which concrete cannot. And this is still lime. It's still hydrated lime. The same properties. It has the clay, the bentonite in it. It has just been turned chemically to stone. And you can go farther. Like I said, the next 5 could build a border wall. Several hundred feet, 30 feet to several hundred feet thick, 50 feet tall, internal buildings, R75 insulation, K50, hypoallergenic, an entire quarantine area. You could make a border wall, instead of being an albatross and an eyesore, you could make it a whelk in the center to humanity. The things that we're doing down and around the world with our business model, global business model, not just American, it's only going to make it worse. It's not going to make it any better. But here it is, folks. This is the building end of hemp. Let's get back and get off the philosophical crap. This is the building end of hemp. Beyond this, it just gets, this is spacey crap here. And the MgO stuff doesn't even need oxygen to cure, so it can really literally be used in space. The, well, even here on out, it doesn't, these don't even need oxygen. This much, no. Let's do this right. Here. These don't need oxygen. Those do. These don't. The MgOs don't even, they need nothing. They bring all their stuff to the party. And, but here's Strength, and I just wanted to show you, you know, an overview of it all. And look at the other videos for the individual strength of all these different things. Like this poor thing this is a used block. It's a test tile. That's why it's got dust and dirty. It wouldn't do this normally. It would be more like this, you know, a harder surface. It did 30 hours at over 600 degrees. And no house, nothing that we build with on Earth could do this. Even concrete fails that test. And some of them were well in excess. The stove, it was turning the plate red. Not the stovepipe. I mean the metal, the 1/4-inch metal plate. It was turning it red. So that can take a torch. From here, it can do some pretty impressive stuff. This is fireproof. Now, don't get me wrong. But to go through hemp, let me get on that too, is the fireproofness of hemp. To lance this, and that's the only way you're going to go through even regular hemp, would take liquid oxygen and a metal powder like aluminum. This would basically be the same. Aluminum powder and liquid oxygen would probably get you through all that, okay? It would start to fail about here. This is where it would start to fail. Aluminum powder and don't get me wrong, some of these you might even have to put in like iron oxide into the aluminum powder to make, you know, to get the liquid oxygen to lance this. And when I say lance, I mean burn through it. It will not burn through. You could douse any of this with gasoline, any of this with diesel fuel, let the fuel completely burn out, and it would do less damage than that. By far less damage than this. That test was so extreme, it was just crazy. But from here on, even that, you're not going to lance this. Not without definitely changing the metal composition of the lancing material. Liquid oxygen, yes, probably even helium. From here on out, definitely the next step, it would take 5,500 degrees to even, well, it won't burn it, but it will melt it. It has a melting point or a boiling point, I should say melting point, not boiling. But it has a melting point that starts at 5,500 degrees this next step. And this is 10 times stronger than those. And this would be like, well, it's just lunatic strength. If you built a house out of this, man, you could hit it with a dozer. You couldn't tear this up if you tried. And it holds organic beautifully, is what I'm trying to get at. The next ones turn organic to crystalline stone. That's the difference in the chemistry. And so, like, you couldn't burn your way through granite. Well, the next ones you couldn't lance your way through either. But okay, YouTube, I thank you for your time. And like I said, this is non-toxic stuff, all what I use. And I don't believe you should be poisoned in your own house. And hemp can not only lock away, sequester carbon dioxide as it's growing and grow faster in a 20-week period than a forest of 20 acres can do in 20 years. But it can sequester the radiation from bad ground, you know, I mean, from dirty soil, and it can sequester, it can bring up and trap the, what do you call that? The pollution from oil spills. It's quite a unique plant. And so like a border wall, back to that, a border wall built to that, yeah, you could sequester quite a bit. Is security real? Yeah, it is. You know, do I want a border wall? No, I spent my military career taking down walls. But is it real with our business plan for the global? Yeah, and we're not going to change. We're capitalist and we're greedy, and, you know, it's not going to get any better. So we might want to consider something different, but make it green and, you know, as toxic as a vitamin. And even those, the next 5, literally as strong as super strong as those are, they're still only as toxic as a vitamin supplement. That's the whole thing about this. There's nothing toxic here. And people that dog Portland, okay, yes, they do put in it's like a bentonite. It's an ite. It's a clay, but it's a triite, and it has to be heated, and that it gets its bad name because they're not only heating the volcanic material, they're heating the lime, and they're heating this clay to make it super dry to make the mix. Could you do that with lime in your own bentonite? Yes, you can. You don't have to have it like that. And that's basically what this is. And it's just as strong as, quite a bit stronger, actually. In acrylics, acrylic monomers that can grow roots into organics that allow the minerals to actually bind. That's the next step up. And then you progress on. You know, these are PLA type adhesives and stuff like that, waterproof below the waterline. Well, I thank you for your time, and if I can help in any way with the hemp project, let me know. Comments below, like it and subscribe and all that kind of happy jazz. And, well, I appreciate everything that everybody does, especially the comments. I enjoy the comments. All right, y'all. Have a big day. Bye-bye.